hayaan niya lang kung mag-play yan. Para may background music habang nagsasalita ako.
Okay lang?
Okay lang. Hinaan niyo na lang.
Tapos pakian mo nga. Tapos ko na yung... Hindi, dun mo kasi makikita eh. Close na natin.
Dito na lang po. Dito na lang po. Close window. Then wala tayong music dito, ma'am. Yung ano na lang. Ganito gawin mo. Okay naman. Dito na lang, nakalakas na to, dito na lang hina. Para if nag-invocation tayo, ma'am, malakas na siya agad. Yung ano. Ano ba? Na-close, sorry. Control Shift T. Lagyan niyo na siya doon, ma'am. Share.
Okay, hello everyone. Good morning, good morning. Welcome to the Quantum Computing Hackathon here at Cebu. Hello sa mga kasama natin that are watching on YouTube. And yes, so if you have some friends that are still not in the area, please message them so that they won't miss anything. So before anything else, we would like to ask everyone to please rise. Let's stand up. Okay, sorry. Okay. We can sit muna po. Okay. Testing lang yun. Testing. Sure thing po. Pero yeah, welcome guys. We're very excited that you're here with us. Ayan, naka-uniform na tayo lahat. Okay, ayan. So we can... Test lang. Ma'am, enough. Hello, everyone. For those that are not yet seated, please proceed to your designated positions as we will start in a few moments. Thank you. And also, your group mates that are still not here, please message them so that they can uh, go here quickly. Sige, ma'am. Music muna tayo.
Hindi dumating na ba?
Second team ng SCR. Sabi ni Sir Bob, let's welcome them pa rin. Pero syempre mag-adjust pa. Let's relocate na lang po yung mga bags. Hindi mo na si Ma'am. Hindi ba? Okay, hello. Ayan, take two. Okay, hello everyone. Good morning again. So, we're here at CITU for our quantum computing hackathon. So, we welcome everyone. But before anything else, we request everyone to please rise as we have our invocation and the singing of the Philippine National Anthem. Malakas na.
Mga kababayan, ang pamang awit ng Pinas. Kayang magiliw, elas ang sinakanan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, kuya ka ng magiting, sa manlulupin, di ka pasisingil, sa nagatak tutok sa simoy at sa langit mo pagaw, ay hinatang tula.
Okay, thank you for that. You can now indulge at the comfort of your seats. Okay, hello everyone. So, can you tap your katabi? Ayan, tap niyo yung katabi niyo and kamustahin niyo muna sila. Kamusta ka po? Ayan, hello, hello. Give them your smiles. Hello everyone. Ayan, so let's welcome some of our participants as well. Okay, so before anything else, no, we would like to ask Mr. Gregory B. Escario, the Vice President of Administration here at CITU, for the opening remarks. Let's give him a round of applause. Thank you.
Okay. Good morning, everyone. On behalf of CIT University, the whole community, administration, faculty, and staff, I'd like to welcome each and every one of you to our Wildcats Innovation Lab, here in CIT University. Um, I'd like to thank, of course, DOST, ASTI, and One Quantum PH, for choosing us to be the venue of this hackathon. We are indeed very honored to have such brilliant minds here with us, from different schools. We are very much humbled for this opportunity. I tried my best, to understand quantum computing. I tried to read a bit about it, pero hindi man makaya, no? So it's really I think I know my limitations basically. So I leave it all to you, the students, those who have the capacity and the fresh minds to really understand, and bring this technology here to the Philippines. All I know is that there is huge potential, and that with quantum computing, there are big names, I guess, backing the development. I can see, of course, I saw earlier IBM Philippines. IBM in general, and all other big names are definitely putting their resources, their money, their investments, into this technology. So we know that that is a good sign that we are, I guess, heading in the right direction. And here in the Philippines, we need to take part, in this journey. So I'm again very glad, because it boils down, the way I understood it. What really struck me was, when I read, is that it's an exponential increase in computing power. Sakto ba? No? So basically, what we're trying to do, I guess, is just the same old problem solving. We're trying to solve problems. We're trying to um, understand better where we are, in this universe. But we have the tools now to, which is quantum computing, to help us get there faster and to help us find solutions faster. So I'd like to thank each and every one of you for being here, for taking on the challenge, and of course the organizers. Once again, One Quantum PH and DOST ASTI, and our CCS counterparts, Dean Sherry, Dr. Chris is here, and our counterparts in the other schools. Thank you for taking part in this, and good luck to everyone here. Good morning.
Thank you po, sir. Again, you said that thank you for choosing us, you said. But no, One Quantum and our partners would like to thank you for the very warm welcome that you have here. So earlier, kahapon or Saturday, we came here, and yeah, we were amazed by this venue. So palakpakan po natin the venue also very here. So yung topics as well, magaling natin. So yeah, okay. So again, I forgot to introduce myself pala. So I am Javis Isaacs, you might already know me for since October. So yeah, I'm director of operations here. And yeah, for at this moment, together with One Quantum DOST, would like to welcome every one of us. So maybe call on, though he's not here, Sir Dr. Franz, De Leon, the director of AOST ASTI, sent a video message for everyone.
Morning, everyone, and welcome to the Quantum Hackathon 2023. I'm thrilled to see so many brilliant young minds today. I am delighted about your interest in exploring the world of quantum computing. Let me tell you this event marks the first ever hackathon in quantum computing in the Philippines, and it is indeed an honor to be a part of this historic moment. As you all know, quantum computing is a rapidly evolving field that shows potential to revolutionize the way we live and work, as well as how we conduct research. Quantum computers can solve some essential computing problems in far less time than it would take for classical computers to solve. They can help us simulate complex systems, optimize logistics, and break codes that are currently impossible to crack. The potential applications of quantum computing are limitless, and we need innovative young minds like yours to explore and unlock them. That's why events like this are so critical. By other students, faculty members, industry experts, we can create a collaborative environment that fosters creativity, innovation, and learning. Let me express my gratitude to the organizers of this event: One Quantum Philippines, the OST ASTI, Cebu Institute of Technology University, and University of San Carlos, and IBM Quantum. Without their support and dedication, we would not be able to do today. I also want to thank the Cebu Institute of Technology University for hosting the event and providing us with a hackathon is over the course of several Saturdays. You have learned the fundamentals of quantum computing, the online lecture series conducted by the Philippines and technical research Advanced Science and Technology Institute, or the OSCAST. Today, your understanding of quantum computing will be put to the test through a series of challenges that you will need to solve by applying what you have learned thus far. I urge you to seize this opportunity to collaborate with your fellow participants and, of course, to have. Finally, let me remind you all that quantum computing is still a nascent field. There is so much more to learn and discover. This hackathon is just the beginning of what I hope will be a long and fruitful journey in the quantum computing realm for all of us. So let's start it. Let's explore the world of quantum computing and let's make history together. Go and unleash the quantum revolution. Thank you very much.
Enthusiastic. Okay, at this juncture, we would like to remind everyone that for this morning, we would have some sessions, some keynotes about quantum computing. Thank you, Pastor. And then at the afternoon, we would have the hackathon proper. Yeah. So, chill muna kayo. No? Some are reviewing na already. No? Pero yeah, we would have some talks muna, and then you can rest, and then we will have the hackathon proper later. Okay. At this juncture, I would like to introduce Assistant Professor Noelin De Jesus, the Director of Marketing and Relations here in One Quantum PH, to introduce our resource speakers. Let's give her a round of applause.
Thank you, Jarvis. So, a warm welcome. Welcome. Sa mga participants sa CIP, thank you very much po, CIPU, for having us, giving this as a venue for this momentum event. So, our first resource speaker is the managing partner of Qubits Ventures, a venture capital firm investing in early stage quantum and photonics tech startups. He is a computer scientist, deep technology executive, and startup entrepreneur with more than 25 years experience in innovation, emerging technologies, startup acceleration and ecosystems building, and digital transformation. He also runs a quantum and photonics startup accelerator in partnership with Founder Institute, a global accelerator in Silicon Valley. He is none other than Mr. Nardo Manaloto to discuss quantum ecosystem and investment opportunities. And to present our about the DOST ASTI and their project, we have Mr. Jeffrey A. Aborot. He is currently serving as a software engineer and researcher at DOST ASTI's Computer Software Division. For several years, he led software engineering projects for partner institutions through contract research agreements with focus on information management system and analytics system. He is part of DOST ASTI's Artificial Intelligence Group and involved with the Institute's current AI initiatives and collaborative research projects with the academe and other government agencies. He currently serves as the project leader of DOST ASTI's Gould.ai project and its most recent initiative focusing on quantum computing and quantum circuit simulation in a high-performance computing environment. And as technical lead in the OST ASTI's Artificial Intelligence Project, ASTI Labeling Machine under the ongoing SKI PINAS program. And for our afternoon resources speaker, he is an independent quantum algorithm designer. He is known for his contributions to the field of quantum computing, particularly in the design of quantum algorithms. He has evaluated numerous quantum computing frameworks, platforms, and utilities, and has shared his insights and findings through his writings. Mr. Siegelwachs is also an author and has written books such as Dungeons and Qubits and Choose Your Own Quantum Adventure. He regularly writes on Medium about various topics related to quantum computing, and his work includes practical applications of quantum computing, reviews of quantum computing products, and discussions on computing concepts. Our afternoon resource speaker is none other than Mr. Brian N. Siegelwachs. Thank you very much and good luck to all participants.
Thank you, Ma'am Noe. While waiting for Sir Nardo. Ayan. While we're waiting for Sir Nardo to come in, he's not actually here in the Philippines, so we're just gonna have a Zoom. Oh, he's here now. Okay. Enter the start picture. Sige. Yan na. Ilipat niya na siya. Ay, stop share na kayo, ma'am. Stop share na kayo. Ilipat niya na. Ilipat niya na. And then mag-unmute po kayo. Hello, Sir Nardo. Hello, Sir Nardo. Can you hear us po? Hello. So, ayan. Say hello, everyone, to Sir Nardo. So, here are the students from Cebu, and you can start your talk na po. Good morning po. Hello, sir. Hello, sir. Yes, we can hear you. Yes, sir. Oh, yeah. Can you speak a bit? Yes.
Do you want me to start?
Let's start.
Okay, let me go ahead and share my screen then. Can you enable participant sharing? Okay. Can you see my screen?
Yes, sir. Yes, ma'am.
Okay. I'll go ahead and start. Okay. Well, first of all, thank you everyone for having me present here. My name is Nardo Manloto. I'm with Qubits Ventures, and I'll be talking about the quantum ecosystem and investment opportunities in the space that I get to see almost every day. So this is about my firm, Qubits Ventures. Qubits Ventures is a venture fund investing in pre-seed, seed stage quantum and photonics technology startups solving complex challenges that creates positive societal impact. So I have been around the world looking at each quantum ecosystem. I've been to Europe, I've been to the Netherlands, I've been to Asia, I've been to, uh, uh, of course, the US as well. And I've looked at all of the different quantum ecosystems out there. And why quantum is considered a critical technology because it advances problem solving, right? So think of the classical systems that we have today. Classical systems are what we call deterministic systems, that is using ones and zeros as a switch to basically represent data. Quantum is a probabilistic system. It really represents ones and zeros and both states, including superposition states, and anything in between 1 and 0 could be considered as a compute bit. It also enhances security. For example, post-quantum cryptography, so we can create unhackable systems. It has a huge economic impact. Why is that? Because quantum is considered a macro technology that layers across all different industries and all different technologies as well. It is also considered strategic and of national security importance because of the level of exponential compute it can do and the level of capabilities it provides. It's also globally important because the level of scientific advancement you get using this technology are things we've never seen before. A good example of that would be quantum biology. There's a recent survey here in the US by a large research firm surveying the top 500 Fortune companies. And out of the 500 companies that they surveyed, 85% of them are already doing proof of concept in quantum. The other thing that they found out that from a use case perspective, we only know about 10% of the use cases for quantum technologies. The 90% are still unknown. So that gives us a lot of opportunities for scientific advancements. So let me talk about the global quantum ecosystem in terms of what I see. So the global quantum investment landscape in the year 2021, there were 18 countries that had a national strategic initiative. That the total budget for that totaled was around $24 billion. In year 22, it increased from 18 to 25 countries, and the budget had increased to $30 billion. This year, it's 30 countries with $39 billion. Here is a good map of the quantum effort worldwide. This is year 2023. You can see all of the different countries in here. And we should be all proud. We should be very proud Filipinos here, because if you take a look at this line here, the Philippines is represented by 860 million pesos, which equates to 17.2 million to do quantum strategy. And this is growing by the month. So let's take a look at 2024. Just this month we added Ireland, which is not here yet, but we added Ireland because they just said that they're doing their quantum strategy. So next year there will definitely be more. So let's take a look at the global market size for something like this. McKinsey and Partners predicted that quantum computing market will reach 1 trillion by 2025. The global quantum technology market will reach 42.4 billion by 2027 by Research and Markets. If you take a look at this, one of the technology that is also key in quantum computing and quantum technologies is called photonics. So photonics is a very mature technology that's been around for a long, long time. It's going through a re-innovation process. So the value of photonics technologies, 590 billion in 2020, expected to reach 1 trillion by 2026. Why is that? Because all of the quantum computers that you currently have there, all the different types that we have, whether it's superconducting qubit, whether it's ion traps, neutral atoms, topological qubit, or photonics-based systems, or NV diamond system, all the different types of quantum computers that we have out there, always have this component in them. Another big consulting group here called BCG estimates that quantum computing, not technologies, quantum computing alone will create a value of $450 billion to $850 billion in the next 15 to 30 years. So let's take a look at the growth from a startup perspective. So on the year-by-year basis, it's been growing. The biggest boom was between 2021, 2022. It's plateauing a little bit in 2023 just because of some financial issues that we had from a venture capital perspective. I think the other part to it is there's a little bit of a slowdown from the creation of new startups, new quantum tech startups, mainly to create such a company. We're hoping that it should increase by next year as well with a better venture capital landscape. So let's take a look at universities with quantum research and development. Globally, there are 180 universities and colleges that have a quantum program, quantum information science program. The US has the majority of it, 71. But I was so happy to see that the Philippines is represented here by 3. as well. So university, college, even uh, people are starting to create some education programs. So you would see high schoolers here in the US, in the UK, starting to actually about technologies. So, like, I've done my research in the Philippine quantum ecosystem, and this is what I basically analyzed. So we are very nascent in the journey. So we're basically really just starting off. So I did a little bit of a SWOT analysis on what the Philippine quantum ecosystem looks like, right? So from a strength perspective, we have a lot. We're growing from an IT and technology sector. We have a strong STEM program with educational institution. You have a young tech savvy workforce, but our weaknesses are quite large. We have limited research and development in quantum. We have inadequate technological infrastructure for advanced research. We have funding limitations for quantum technology initiatives. A good example of this is previously in the slide that I showed you a map. A good example would be comparing the Philippines to China's quantum budget. China's quantum budget is 25 billion, and our budget is less than 20 billion. 20. Okay. But we have, in any nascent area, we have a lot of opportunities. So we have potential for collaboration in quantum research, and I see this trend across many different countries where they collaborate with more advanced countries in the quantum space. You can incorporate new quantum computing into your educational curriculum, even on a high school level, college level. And then you also have an opportunity to become a regional hub for quantum technology. Some of the threats are basically the pace of innovation for quantum is so fast, we may get left behind here. Competition for other countries developing quantum programs. Other countries are definitely much more aggressive. And because of that, people may see different opportunities in other countries, which will cause another brain drain of skilled professionals. However, we have a lot of great building blocks when it comes to quantum for the Philippines. Here are all the different things that I've seen that comprises of the ecosystem in the Philippines. We have universities like UP and University of San Carlos that are already doing work in quantum. You have a great research organization, a DOST. You have a quantum ecosystem builder, One Quantum Philippines. You have a national quantum budget, although it's a small budget, but it's a good start. You actually have created a quantum technology roadmap. I'm not sure whether you guys already know that. You have many different quantum-friendly industries, so industries where quantum really applies. Some of the other key strengths that I see as building blocks for the Philippines, semiconductor and electronics manufacturing capabilities is actually quite strong there. So in the world of quantum computing, there's going to be not just computing, there's going to be sensor development, electronic development, component development. So I think semiconductors and electronics manufacturing will play a key role. We have a lot of software engineering talent, AI and data science. We have large BPO capabilities. We have a thriving startup ecosystem. We have country and city economic development and support groups. We are rich in natural resources. So this is a big deal right now. There's a lot of critical resource summits that's being held around the world talking about, okay, what are we going to do when it comes to harnessing those natural resources? Because these resources are needed for the creation of quantum and quantum sensors and computers. So we have to make sure that we know how to use it for our own use and not only for the use of other countries. We have capabilities in mining and mineral processing, which supports component development, semiconductor development, chip development. We have an increasing entrepreneurial mindset, which I see There's so many accelerators and startup incubators in the Philippines now that it's actually quite amazing. And hopefully I become part of that building block. I hope to invest in quantum startup companies that comes out of Philippines, and hopefully maybe something in this hackathon as well. So here's our existing quantum capability. So UP Diliman, National Institute of Physics, they have quantum foundations. They do mathematical physics, photonics, condensed matter physics, quantum entanglement, cavity quantum electrodynamics. UP Baños does computational material physics, quantum chemistry calculations, quantum mechanics, quantum transport, thermodynamics. University of, yes? Was there a question? Okay. University of San Carlos is also in theoretical and computational condensed matter physics. And then you have DOST for advanced science and for artificial intelligence and compute models. So let me talk about the Philippine Quantum Technology Roadmap. So actually, if you take a look at in the map that I showed you, the budget was stated at 860, but in the quantum technology roadmap, it's actually 950 million. So I'm not exactly sure which one is correct. I hope it's this one. So it's a much larger number. So this is the roadmap for the Philippines. We have a 7-year roadmap. If you take a look at where we want to be by 2030, the Philippines will have a quantum-enabled economy by developing its own quantum computer, network, simulator, and metrology. That's in the span of 7 years, folks. Okay, do you think we can do that? I am hopeful we can do that. So if you take a look at the roadmap, right? So here are, if you take a look at the left-hand side here are the things that they want to build, right? Facilities like a quantum tech R&D center, connectivity infrastructure. There's probably cloud services for quantum computing. So quantum computing as a service. Establishment of a design, fabrication, and characterization facilities for materials. So this could probably be on the nano fabrication side of things. And then many different things, right? Human resources, R&D for quantum communications, quantum computation, quantum materials and simulation, quantum optics and sensing. This is the photonics portion of it. Okay. So initially, establish a quantum circuit simulation using HPC, and then move up in capabilities every year, so on and so forth. I think based on the legend here, since the font is still red, I think they're still trying to ramp this up. Okay. Quantum literacy is big around the entire the world. There are so many colleges and universities having quantum information science now. I'm not even sure whether we have quantum information science in any of our universities yet, public or private. So I think to make sure that we need to have programs like that from college, masters, and PhD programs. Small to large businesses also need to know the use of quantum and security. High school are also getting trained in quantum technology. So this is part of workforce development. They want quantum technologies. They want people who knows how to support quantum technologies and computing. So these doesn't have to be PhD level or master level people. These could be high school and college level people that can do this work. Government and policymakers also are into quantum workforce development. cybersecurity, like post-quantum cryptography, quantum random number generation, and quantum key distribution. And then, of course, the startups and entrepreneurs are also looking to learn about quantum technology stack and supply chain. And why this is so is because the majority of the companies being formed from a quantum tech startup perspective are all scientists and engineers, and hardly anyone from the regular, the deep tech side or the regular business person starting up a quantum company. That's not usually the case. Usually the scientists and the researchers and the professors that are found inside of universities and colleges are starting up these companies. So we need to make sure that anyone can start up a company like this, but by just hiring the kind of people. Okay, and then I took a look at what are the industries in the Philippines that we have that are friendly to quantum. Okay, so you have information technology and DPO services. So quant software engineering, data science and AI, quantum business process outsourcing, agriculture. Okay, so there's a lot of stuff you could do with agriculture. In my next slide, I will show you a list of different applications that you see as opportunities that you can build upon. Manufacturing as well, mining, mineral processing, sectors, electronic, shipbuilding. We are very with that. There's a lot of application that could be done for manufacturing, healthcare, pharmaceuticals, telecommunication, transportation, and logistics. Okay, here's the list of opportunities in quantum applications. I didn't give you the entire list. I pretty much have a book of all the different use cases that you can have for different types of industry. In my last count, I have over 400 different applications that are quantum enabled. So from an agriculture perspective, you could do things like climate and weather prediction, pest and disease detection. You could create computational chemistry for new kinds of fertilizers that is more climate friendly. From a manufacturing perspective, you could do supply chain optimization, process optimization, predictive maintenance. For healthcare and pharma, drug discovery, personalized medicine, genomics analysis, telecom, quantum cryptography, quantum networking, quantum computing for networks. For supply chain and logistic, a lot of it is really optimization of logistic and routing and last mile supply chain. And then there's this new field that we call QAI, which is really quantum and AI banded together. This is definitely a little bit cause of concern because really what this is exponential computing plus artificial intelligence will actually create exponential intelligence, right? So this is an area that is a big discussion around the globe now. For example, you saw recent news about OpenAI. This is the area that they're tackling because they're starting to get into creating algorithms that are more quantum-based. They're seeing the start of exponential intelligence, and these algorithms are becoming self-taught, right? So the other point I want to make here is anything that has an AI component in what you do, you could actually create a quantum. You can fragment the algorithm to also have a quantum component. So the new approach that we have for quantum AI is really more on the hybrid side, right? Hybrid computing, where the hardest part of the algorithm is done in quantum and the easiest part of the algorithm is done in classical. So you basically put the two together and create the results in a quantum computer, create the results in a classical computer, bring them together to create the full outcome. So this, I wanted to spend a little bit of time on this one. This one is it's a very technical diagram. There are a lot of opportunities in the quantum stack. So if you take a look at this quantum stack, anywhere from the quantum materials, quantum devices, environments, components, controls and corrections, software, network, quantum products, cloud services, algorithms, applications, and industry applications. Okay, there's definitely a lot of this stack, quantum tech stack, has a lot of potential opportunities here. There are opportunities from a venture capital perspective that are considered, unicorn opportunities, like building a quantum computer, right? So that could be a unicorn type companies, but the majority of these type of businesses are what I call lifestyle businesses. So, you could create a company that can make, anywhere from 10 to $50 million a year by just creating these things, right? So, for example, if you go into the area of components, right? So having a HD connector and wiring company, an IO company, a laser company, right? The tech, those are not going to be unicorn type companies, but they could be good companies in itself, right? That can make you 10 to $50 million in their revenue. Things like I would say devices. So memories and sensors are not gonna. It's gonna give you a good return, right? If you create one kind of sensor, let's say like a quantum magnetometer or a quantum accelerometer, but it's not gonna give you a $1 billion type company. Okay, so I'd like you to consider thinking about, the separation between a lifestyle company and a unicorn type company by looking at this stack. So these areas, industry application, are for the end users. These are for the service providers, algorithms, cloud services, hardware and software are pretty much supply chain as well. Majority of these are not companies. And then the material, so the Philippines could be good in this area because we have natural sources. Think about maybe starting an advanced material type company as well. So other opportunities in building the ecosystem. So, in order for us to create excitement and education in the Philippines, we need to create large quantum tech conferences. So far, I haven't seen one in the Philippines. There's one, the nearest one is from Singapore, industry conferences. So in like advantage of many opportunities in the quantum supply chain and tech stack. And also, we can become a competitive country in key areas of strength. Thank you.
Thank you, sir. So at this juncture, we won't have any time for Q&A, but instead, I would like to ask, what can you say to our future innovators here? We have around 30 young students and coaches on how they can start up. How can they start their own startups in quantum technologies? A short question.
Yeah, so the advice I would say is, quantum technologies are great, but the best thing that you can do is be in front of your customer and really know
in depth the problems that they're facing. Quantum
just
is
a
just a
way
way for you, it's just a different way and approach for you to solve a problem, but the problem is still the problem, right? So the, the better you know the problem, the closer you are with the customer, the better you are off in creating your quantum tech startup. Just because you're not a quantum PhD, you're not a quantum master student, doesn't mean you cannot build a quantum startup. Go ahead and build the quantum startup. The resources are always there, the knowledge are always there, and the people are always there to help you. So don't be afraid. Go for it.
To probably even start thinking about their own startups. All right. So, Sir Nardo, Sir Bob will be here with you shortly on this. Again, everyone, let's give Sir Nardo a warm round of applause for that. At this juncture, we would like to call on Mr. Jeffrey Abora, the Supervising Science Research Specialist at DOST ASTI, to give a presentation about what they've been doing in ASTI and the quantum computing simulator project.
Yeah, hello. Hello, good morning. Wow, it's nice to see fresh faces, no? And I would say that you're very fortunate to be at this stage in your education. Because it's like witnessing the emergence of. So it's like witnessing the emergence of ano, no, mainframes. Back in the early days of computing, kasi we are witnessing the emergence of a new type of computing. I guess you're familiar with GPUs and how we can use GPUs to improve the efficiency of computation through parallel computing. So using GPU computing. And now we are witnessing another type of computing, which is quantum computing that utilizes some quantum mechanical effects for computation. So before they thought na parang nuisance to mga entanglement, tunneling, kasi dahil sa liit na ng mga components for computing, nag-occur yung mga effects na hindi na-observe before, no? Sa early developments pa ng mga processors. But this time, these effects are occurring and they thought na, how about to make use of these effects to gain advantage in computing instead of just treating these effects as nuisance. Okay, and of course, sa theoretical computer science, sa theoretical physics, they went on to discover advantages gained when utilizing these effects for computation. Okay. So, I think once lang yata ako nakapag-lecture so far pa do sa series, and it's about quantum algorithms, which is somehow yung culmination ng mga past lecture series. Kasi doon yun na ipagdidikit-dikit yung mga gates sa circuits para makabuo ng something somehow useful na output. Kasi using one or two gates is nice, but combining these gates to solve a computing problem is the goal, no? So the challenge is how do we organize these gates so that we can solve a difficult computing problem. So emphasis on the difficult computing problem because quantum processors will be maximized when solving difficult problems. No? Kasi yung mga word processing task or internet browsing, our CPUs can do that. Yung mga yung mga daily tasks, computing tasks, can be solved efficiently by our CPUs. But yung mga computing tasks like finding the optimum configuration of a system, finding the optimal route from point A to point B, these are difficult stuff. And ito yung mga nabanggit kanina ni Sir Carlo that we should be looking for. Because at the end of the day, quantum processors or quantum computing is just another type of computing. It's just a tool, no? A tool that we are trying to discover, trying to understand, so that we can use these tools in solving current difficult problems, no? So hopefully, using quantum processors, mas mapapabilis yung pag-compute nitong mga problems na to. So that's the goal, no? Mapabilis yung pag-compute ng difficult problems. Kasi difficult problems tend to have an exponential growth with regards to time complexity. I think na-discuss ito in one of the lectures, I think kay Sir Elmer, yung sa complexity theory, which is yung time and space complexity. And na-mention ko rin yung sa circuits, circuit complexity, oracle complexity, or query complexity. So these are metrics in measuring the effectiveness of algorithms, no? So we want to bring down the complexity. So we want to be able to solve problems much faster, more efficiently. So like for example, yung sa AI, I think exposed naman na tayo sa current stage ninyo in your education. You are very exposed sa implementations ng artificial intelligence. For example, ChatGPT or computer vision models. We know that we can develop AI models using GPUs. But if gagamitin na natin yung model for inferencing, it takes time. Kasi malaki yung mga models sometimes, no? Lalo yung mga computer vision models, large language models. Because these is composed of a bunch of numbers that imagine a large matrix, no? Na binabangga natin doon sa vector representation ng inputs natin. And if mapapabilis natin yon using quantum computation, then that would be nice, no? Let's say cloud-based na quantum computation. So mas mapapabilis yung computation and mas ma-open yung doors to other use cases na hindi pa natin na-imagine kasi before naisip natin mahirap siya kasi magastos sa computation. Okay? So and yun, yung on the side cloud technology is a very key technology in bringing quantum computing to everyone, no? Kasi expensive yung magkaroon ka ng sarili mong quantum processor sa bahay, no? Even yung cost pa lang ng electricity, it is ginormous, no, for you to operate one. Okay? So this morning, I was tasked to just introduce to you about our agency, ASTI, or for short, ASTI, mas cool na tawag sa agency namin, or minsan ASTIG, pag sa mga events namin. So we are one of the, I would say, siguro less popular agencies of the UST kasi yung mga popular usually yung PHIVOLCS, pag may mga seismic activities, pag-asa. Half of the year, we are receiving around 23 typhoons a year. So, famous din yung pag-asa. Kami naman, si ASTI ay for several decades now ay medyo nasa backseat. But nung dumating yung AI, emergence of AI, no, we've been developing AI products since I think 2018. Okay, and ngayon naman nag-emerge yung quantum computing. So we are also looking into it. So ASTI stands for Advanced Science and Technology Institute. So ano no, it's vague, no, Advanced Science and Technology Institute. So what's in it? Actually, scope lang ito no sa ICT. So specific sa ICT, so andyan yung IT, computer science, computer networking, high performance computing, microelectronics, covered din ng ASTI. Kasi yung other sciences, may specific research and development institute si DOSC for that. Okay? So si ASI, ang focus niya ay microelectronics, ICT, software development, and of course, emerging technologies. Kaya nag-fall under ASTI rin yung quantum computing kasi categorized as under ICT. So we are tasked to develop R&D activities on ICT, and then to undertake long-term research and development work for modernizing S&T infrastructure. So when we say infrastructure, ito yung mga back-end side. Ito yung hardware that supports R&D. So later, madadaanan natin yon. And also to complement all endeavor in scientific field with intensive activities in computer and information technology. So si ASI, meron siyang facilities that support R&D on the natural sciences universities. So we enable universities, our partner universities, so that they can do massive computation. Kasi lalo yung mga universities na medyo maliit yung budget, so they can buy their own hardware. So we provide them access to our computing facilities. So para makakapag-generate pa rin sila ng research results, even though wala physically sa kanila yung computing resources. Okay, next slide, please. So I'll just be running through some of the projects, products, and services ni ASI that might be of interest to you. And later on, may isang slide about quantum computing. So we are currently doing R&D work on satellite data sets. So we are doing AI works on satellite capture data sets so that we can do maritime surveillance. So maritime surveillance, ito yung mga nasa dagat ng Pilipinas that we are interested to look into, to monitor so that we can know yung mga activities doon. So alam na natin kung saan ang site niya ng Philippines, no? Yung gusto nating makita on a daily basis. Okay? So that we can have supporting data sa mga reports. Okay? Next slide, please. Also under space technologies, we have subscriptions to satellite services like Novosar. So currently we are doing 4 times na scan ng Philippines in a day. So let's say may bagyo, may mga landslides, we can capture yung state ng Philippines through 4 scans a day. Okay? And then so ito yung mga sample scans nung Novosar satellite. So dito, I think this is a lake, no, that ASI is also trying to monitor yung activities doon sa developments doon sa lake. I think it's Laguna Lake. Yun. So ito yung mga space-related activities ni ASTI. So some of these activities have already been transferred to the Philippine Space Agency kasi sila na may mandate to maintain, monitor yung space above the Philippines. Okay. But yung physical facility ay nasa ASTI pa rin. We are also doing R&D work on AI. So this one is one of our projects. This is application of Internet of Things to plant growing. So this is a laboratory scale of a prototype for growing. And this one is ito no. So ito yung project ni Sir Elmer. This is a natural language processing enabled interface for databases ng mga offices. So instead of querying your database, you can just ask about stuff sa company niyo, like how many employees are male that are above 25 years old and with this salary grade. So mag-reply siya sa'yo ng statistics or answer in paragraph format. So ano siya, it's for an office setting. And then ASI Alam, so ito yung jacket na suot ko right now. ASI Alam is a ongoing project of ASTI that is focused in developing computer vision models for processing satellite captured images. Alam is short for ASTI labeling machine. So ang purpose kasi niya is to label satellite datasets. So let's say we want to segment vegetation or urban areas. So nagagamit siya for automatic identification of features given satellite captured images. So we are using deep learning technologies for these purposes. Okay. Next slide, please. And then for connectivity naman sa mga remote areas, so we know that in far-flung areas in the Philippines, may mga areas na kung saan halos wala pang connectivity. So just yesterday, I was in Quezon, and yung resort na tinutuluyan ko, wala siya halos connectivity talaga. And then umaasa lang yung mga tao sa piso Wi-Fi. So I don't know, baka naka-Starlink yung mga yon, and then they just renting out yung internet connection nila. So we are very fortunate to be in areas with very strong internet connection. But some areas in the Philippines still have no internet connection, and ASTI has developed a technology for enabling internet connection doon sa mga far-flung areas. And through the RAIN project, yung mga areas na to can gain access to educational materials even though walang internet connection because they're using TV signals. So yung mga signals na wala namang gumagamit, so doon nila pinapadaan yung mga educational materials so that sa mga local barangays, they will be able to have access to mga courseware, mga course materials, so students can access these materials through a regular computer kahit na offline sila. Okay. So, and ito naman yung ULAD project, this is one of the projects that, on which I was involved. So, and then using these lightning occurrences for predicting yung potential strength ng typhoon na paparating. So ano kaya yung signal ano kaya yung classification ng typhoon na paparating given yung occurrences ng mga lightning, yung dami ng occurrences and kung saan sila sa Philippines nag-occur. So that we can prepare in advance doon sa paparating na bagyo. Okay, so this is in partnership with the Japanese government. Next slide, please. So for mobility naman, one of ASIS projects, Project Virus, so this is para siyang IoT for vehicles. So through V2X or vehicle to everything, kayang makipag-communicate ang mga vehicles dito sa mga infrastructure natin, like mga stoplights or mga towers, and also other vehicles so that pwedeng ma-automate yung operation ng traffic sa road. So ito currently yung develop ni ASTI, which is para siyang automated na display with traffic signals, so using computer vision technology. So hindi lang Internet of Things but also vehicle to everything. And then under robotics naman, there is a group in ASI that is focusing on robotics. So ang focus nila is on computer vision na onboarded sa isang mobile robot. So ang target is ma-deploy ito sa mga disaster-stricken area so that yung mga mahirap puntahan can be accessed by mobile robots. This one is a rover type. I think meron din silang unmanned aerial vehicle type. Okay? So may onboard computer vision for person or parang human identification. Okay. Next slide, please. So this one is application of the computer vision on robotics for a plantation na setting. So in this case, automatic na na-identify ng system yung mga banana trees that needs attention kasi may mga diseases na na-acquire yung mga banana trees, and then these machines are meant to go around the plantation in an automated fashion, and then may report lang na na-receive yung operator so that alam niya kung saan siya mag-focus ng attention doon sa buong plantation. So kasi kapag malaki yung plantation, it takes time na malibot yung buong plantation para lang ma-identify ano yung mga banana trees na kailangan asikasuhin. So this is done through the Roamer project naman. And then under systems engineering, so ASI is doing software engineering work. This one particularly is for measuring the quality of internet connection in the different areas in the Philippines. So here, hindi natin ramdam kasi mabilis yung internet connection natin. But in so many areas, actually, sobrang bagal lang internet connection nila. So yung goal ng project na to is to map out the whole Philippines with regards to the strength of the signal nung internet connection, so that ma-reflect ito into a policy para ma-address siya ng relevant na government agencies. And this one, Project Kuha, it is a mobile application for social sensing. So social sensing is a term used for softwares that are used in gathering data sets for research purposes, no? And then citizens yung kumukuha ng mga data sets. So and then yung mga data sets na generate ng mga citizens can be applied with computer vision for various use cases. So ito ang Kuha is now downloadable sa Play Store. And then some other information systems for office setting. This one is a human resource information system for managing employees in office setting. So this one, ito yung related sa quantum computing. So as I mentioned, currently ASI is hosting a high-performance computing facility with petabytes of worth of storage. So the goal of this project is to enable circuit simulation in an HPC environment. So kasi di ba, limited yung access natin sa real quantum processors. And so early simulation of circuits can help us in identifying the effectiveness of our circuits, no? Kasi nga, di ba, pumipila tayo doon sa actual quantum processing resource. So with this one, once na ma-up yung services na to, we can submit job request doon sa HPC ng ASTI para ma-simulate yung mga circuits natin before natin i-run doon sa actual na quantum processors ng kung aling vendor man yan, regardless kung anong vendor yan, no? Kasi marami namang options like IBM, Amazon, Microsoft, no? So for this one is for research purposes kasi we know na as we increase the number of qubits, exponential yung nare-require, no, na time to simulate these circuits, and also yung space din if we will save yung buong state ng step by step na computation. So we are currently using yung Munich Quantum Toolkit. So we are trying to introduce concurrency, parallelization dito sa Munich Quantum Toolkit para ma-execute siya sa HPC much faster. So yung Munich Quantum Toolkit is a set of software tools that we can use for simulating circuits. So this is pinagagalingan nila is actually design automation sa classical computing, yung mga circuits na ginagamit sa mga boards natin. So yung software na dinesign nila for circuit simulation is actually ginagamit na before for classical circuits design, verification, analysis. In-extend lang nila into the quantum setting. And as is also currently hosting yung receiving station, ground receiving station ng mga satellite subscriptions natin, and also ng mga sarili nating satellites, like yung mga Maya satellites. So nare-receive sa ASTI yung mga data na yon and then pinaprocess din siya sa ASTI for various purposes. So currently we have 3 stations, one in Quezon City, one in Iloilo, and another in I think Davao, no? So, yun, meron tayong 3 receiving stations kasi pa nagpa-pass through yung satellite, any of these can request yung satellite to capture data for us. So, gamit na gamit siya for disaster response, for risk management natin, especially during typhoon season. So this one also, the Datos project, no, ito yung heavy sa mapping services, so applied with AI. So they were able to develop AI models for mapping tasks. So dati kasi, yung engineers nila, manually pa nilang sinisegment itong mga to. Let's say bumaha, no? So manually sinisegment yan ng mga engineers. But using AI, yung AI model nila can now automatically segment yung mga flooded areas, for example, or mga areas na tamaan ng landslide. So this cuts down the time for processing satellite images. I think to a very, very small percentage na lang ng original time. Kasi nga hindi mo na minamanual na i-segment isa-isa yung mga yan. So currently, na-roll out na nila yung technology and ginagamit ito sa mga universities, mga government agencies na may mandate also for processing satellite images. So yun, i-transfer na rin yun sa PhilSA. And also, ito yung high-performance computing facility ni ASI that supports research work sa universities. So ito yung isang research development center ni ASTI na continually growing. So yung mga sinusupport niya ng mga researches ay on whether simulation, mga genomics, and sa case nung sa quantum circuit simulation, yung simulation ng mga circuits on limited number of qubits. So if you want to access yung HPC resource, we can simply apply for access, no? May online form lang yung na-fill out, and then tatanungin lang kung ano ba yung project mo, ano yung gusto mong gawin using HPC. And once na meron ka ng access, you can submit job request so that pwede ka nang mag-queue ng mga computing jobs mo dito sa core HPC ni ASTI. So we highly encourage na gumamit tayo ng HPC para mas marami pa tayong maging outputs sa R&D sa natural sciences and engineering. And this one naman, ito yung Research Education Network ng Philippines or yung Progenet. So this network connects the Philippines to other countries in the region So malaki yung bandwidth niyan. And kung yung university natin ay affiliated with Progenet, then if we have research collaborations with other universities abroad and we have large data sets that we need to receive from them or to send to them, then we can use Progenet para doon ipadaan yung malalaking data sets kasi malaki yung bandwidth niya. So for example, yung link to Japan is 10 Gbps. So we are used to, let's say, mga 20 Mbps na bandwidth. But this one is 10 Gbps. Okay, so kung may mga datasets tayo na ginagamit for AI, AI engineering, and then may collaborator tayo sa Japan, then this is a good avenue para mabilis yung exchanges natin with these partners abroad. So this is a product of ASTI for environmental monitoring. So kinakabit itong module na to sa mga automated weather stations ni ASTI. So I think this one is for monitoring sa mga rivers. So ito, ano siya, minamanufacture na. ARQ yung tawag sa kanya. So this is just a, parang zoom in view ng ARQ. So I think for mga nasa engineering, electronics, so mas appreciative kayo sa mga ganitong products, no? Unlike me na software guy. So sa next slide. And this one, so in-incorporate yung ARQ sa mga different automated weather stations na produce na ni ASTI at currently ay minamanufacture sa market. So ginagamit ito ng Pag-asa for automatically monitoring yung weather conditions natin. No? So they can work on the datasets na napaproduce nitong mga to. There are thousands of these deployed nationwide that produces data, massive data on a daily basis. No? So ngayon, ito na yung full deployment ng mga stations ni ASTI in partnership with other agencies also like Pag-asa. So we are basically covering the whole Philippines. No? So may mga datasets na naproduce, and if you're interested in doing research on these datasets, then you can just send a request letter to ASTI so you can have access to these datasets for your own analysis. So yung mga into data analytics, yan, you can make use of these datasets. And I think lastly, si ASTI ay for electronics, meron din kaming testing facility sa Bikutan compound. And this is for testing yung compatibility ng mga products na rin-develop natin. So if you are into electronics, makakapag-test kayo ng mga prototypes ninyo dito for interference. Yan. Yeah, so far, yun yung mga projects ni ASTI, projects, products, and services. And if you are interested in any of these, you can just send us an email or follow us in Facebook, Twitter, and other social media platforms. So dito yung email ng ASTI. So, for example, if you're interested in gaining access doon sa HPC, so you can just simply search yung CORE, COARE, and then my online form na you fill out. And then just a very brief process na worth it kasi makaka-gain kayo to petabytes of storage and massive computing resources. So, thank you.
Awesome. Thank you for that. Ayan, very exciting yung mga projects ni ASTI, right? So yeah, as Sir Jeff said, no, parang laid back sila. Pero yeah, I personally, I was really amazed on the projects, the lineup of projects. No? Halos lahat na tatamaan nila. And yeah, personally, I want to work on ASTI na. Nagsasearch na ako ng mga job openings doon. Kahit na second year pa lang ako. Ayan, sige, hopefully, some of you would also be there with us. And even if not particularly employees, diba? So we can partner with ASTI for research purposes as well. Okay, at this juncture, our morning session is now concluded. At this point, you can now rest and let's wait for
our lunch to arrive. Alright, so yeah, you can prepare for the hackathon na and you can have a break. Okay? Again, yung CR natin is diretso lang kayo dito and then take a right and then take a left. Alright, thank you very much.
while I do consider myself still quite young and techy, but I do not know much about quantum computing. Most what I know about the word quantum, I've only learned that from sci-fi movies or from other comic book movies such as Ant-Man, Quantumania. Di ba? Pumunto? Pait talaga eh. But I do know enough that today we stand at the precipice of a technological revolution, one that promises to make quantum leaps into the realms of new possibilities. Quantum computing, with its ability to harness the mind-boggling properties of quantum mechanics, holds the key to solving some of the world's most pressing challenges, from developing life-saving medicines to designing materials with extraordinary properties. For Cebu City, this budding field of quantum computing presents a unique opportunity to become a global hub for innovation and discovery. Very much aligned with our mayor's vision of a Singapore-like Cebu City, I must also say with much pride that with its vibrant academic landscape and growing pool of talented individuals, Cebu is well positioned to make significant contributions to the advancement of quantum technologies. I thank our friends from One Quantum Philippines, our esteemed researchers from DOST, ASTI, for not only making this possible, but for stirring up the interest. As more schools and academic institutions embrace quantum computing, I believe we are witnessing the emergence of a new generation of quantum enthusiasts eager to explore the vast potential of this field. The inaugural Quantum Hackathon of yours is an embodiment of this enthusiasm, providing a platform for aspiring quantum innovators to showcase their creativity and problem-solving skills. So congratulations to all of you. Pakpak, pakpak. As we embark on this journey of quantum exploration, if I may so call, allow me to leave you with the words of a physicist and inventor. And this guy is not so popular. This guy is named Nikola Tesla. You know him? Okay, you know him. And he once said, "Today science begins to investigate non-physical phenomena. It will make more progress in one decade than in all the previous centuries of its existence." Imagine. So today, we stand on the threshold of a new era, fueled by the boundless potential of quantum computing. Let us embrace this opportunity with open hearts and open minds as we help shape a brighter and better future for Cebu City and the world. So kaninyong tanan, congratulations on this event, and good morning, good noon to all of you.
Of course, to show our appreciation, I would like to call on Sir Bobby Corpus to award the Vice Mayor for a plaque.
So I will read the what's in here now. Sir, thank you very much. To Vice Mayor of Cebu City, Honorable uh, Attorney Raymond Garcia, in acknowledgement of his outstanding dedication as a passionate advocate that supports the progressive change and innovation, leaving an enduring impact on the inaugural event. His presence at the gathering serves as a powerful example setting a noteworthy precedent for future events in the country. So, presenting to you, sir, this lack of appreciation.
Thank you so much. Thank you. Wow, thank you so much. Thank you. Okay. So again, thank you once again, huh?
Okay. Thank you for that. Okay, at this juncture, no, enjoy our bountiful lunch. So wait na lang kayo on your seats and we will serve it to you. Okay?
So I'm hoping everyone is already full, everyone's ready. Um, everyone can't wait for the hackathon proper. So for our next speaker, he is going to talk about the current state of quantum. Ladies and gentlemen, let us all welcome Mr. Brian Silumax. Round of applause.
Next slide. Need to know about me. This is a real quantum computer, by the way, a superconducting quantum computer, one of IBM's. Next slide, please. I'm going to talk about stuff. Next slide, please. So what you need to know first is that there's a lot of hype. Everything you hear, everything you see, you want to question it. There's a little bit of truth, a whole lot of misinformation. Part of the problem is popular science, they want to get you to read, so they exaggerate the titles, they exaggerate the news. Part of the problem also is if you're a journalist, how much do you know about quantum? So there's a hard to understand paper, there's an article that summarizes it, and the journalists just repeat it and it's inaccurate. So you want to ask a lot of questions and verify what the news actually is. Part of the problem is also the companies that are trying to make money off of it. So there's a company in Australia that claims they are making a quantum computer with 1 billion qubits. If you look at their research, they're still working on 2. So they're saying 1 billion, and they're still trying to get 2 to work. There's another company that's selling a quantum computer that doesn't even exist. If you buy it now, they hope to deliver it to you at the end of next year. And there's no guarantee they will accomplish that. And even if they do build it, there's no guarantee what the quality will be. Then you also have problems that as achievements are being made in quantum, achievements in classical computing is catching up. We are still making advancements in classical computing while we make advancements in quantum computing. So these advancements need to be achieved and stay achieved. Then you also have a lot of solutions without problems. Quantum computers can do something exponentially faster for problems that we have no use for. So they're demonstrating that quantum computers can do it, but we are still in search of more problems that we need to do it for. Next slide, please. So what is not hype? You'll see this quote from Professor Feynman about the way to understand quantum systems is with quantum systems. So that's very true. As we're building quantum computers, we are learning a lot about the physics. We're learning about a lot about engineering. We are learning a lot as we're building them. Then you'll hear that quantum computers can generate random numbers, but they don't have to be perfectly random. We can encode patterns, so we can generate art, we can generate music, we can generate language. Could you click on the speaker thing? Hopefully this works. Can't hear it. Well, if it worked, there it is, sort of. so that was composed last year. That was composed with a real quantum computer that generated the notes, and then we applied a vocal synthesizer to make the quantum computer sing. This year's version has multiple instruments playing at the same time, but it's not published yet, so I can't share it. But so this is something that we can do today. Also, something that does not appear to be hype is the energy consumption. Nobody seems to be arguing against that. Supercomputers use a lot of energy. So even if a quantum computer is the same speed, there's still a huge savings in cost just by consuming less energy, plus it's much friendlier for the environment. Next slide, please. So some of the technologies that exist right now in the top left here, that's a superconducting quantum processor. That's actually the first one that was ever put online by IBM about 6 years or so. And what you want to pay attention to are these little squares in the middle. Those are the qubits. So this is regular electronics. They're actually simple electronic circuits. And if you study electronics, circuits have resistance. And in fact, we add resistance to do different things. But what we do is we freeze them down to temperatures colder than outer space. They're very close to absolute zero. And what happens at that temperature, the resistance disappears, and the electrons are free to zip, zip, zip around. And we create the behaviors of atoms. You'll hear the term artificial atoms. We're not actually creating atoms, we are creating behaviors of atoms. So when we're doing these lectures and we're talking about 0 and 1, what does that actually mean? So in these little circuits, there's a break, and the electrons cannot pass through there because that's what a break in a circuit is. So the 0 is the electrons not flowing. So what is a 1? There's a principle in quantum mechanics called quantum tunneling, where the electrons, even though there's a break in the circuit, they can go to the other side anyway. Because the particles are not actually particles, they're waves. So if the wave extends to the other side of the gap, the electrons can just say, I'm over here now. So 0 is the current is not flowing, 1 is the current flowing, and then the superposition is, we don't know. It's in a state of flowing and not flowing at the same time, probabilities of each. Then the top right, that is a three-dimensional array of neutral atoms, which we probably won't have. The companies seem to be leaning towards 2 dimensions. And in that case, 0 and 1 is a difference of the energy level of the atom, and you probably won't see 1 soon. It's 0 in Rydberg, but that gets kind of complicated. But the energy levels of atoms, and in the math that we spoke about, trigonometry and linear algebra and all that stuff, you solve the problems with geometry, different kind of math. The bottom left here is a quantum dot. You can see the scale is 1 micrometer, so 1/1,000,000th of a meter. And there's different implementations of this. So what is a 0? The intrinsic spin of 1 electron. We can trap 1 electron in these things, that even though they have such a small size, very small charge, very small mass, we can trap 1 electron. So spin up might be 0, spin down might be 1. So as you're building your quantum circuit and you put in an X gate, which is the first gate you'll learn in the upcoming hackathon here, the first one you'll use, if one of these was active, it's offline at the moment, a new one is hopefully coming out soon, you're ordering this multi-million-dollar machine to change the intrinsic spin of 1 electron. Then another version, there's a double dot system where you have 2 quantum dots and you're playing a game of where's the electron. So if the electron is over here, that might be 0. If the electron is on the other side, that might be the 1. So different ways of building quantum dot devices. The bottom right is a nitrogen vacancy center, so that's synthetic diamond. Diamond is a carbon structure, but you build it, you leave 2 carbons out, and in the place there's 1 nitrogen atom and 1 vacancy, hence the name nitrogen vacancy, and all kinds of different ways to encode information. There's the nucleus of the nitrogen atom, so the nucleus has spin, and then the valence electron, the outermost electron, works like a remote control, like the TV, works like a remote control, controlling the spin of the nucleus of the atom. Then in the vacancy, you can put electrons and play with their spin. And then you have all the carbon atoms around it, and they all have spins. So different ways of implementing that. Then my personal favorite, in the middle, photonics. So right now we are being bathed in photons. They have no mass, no charge. They don't like to interact with anything, but we can use them for computation. So that could be in this racetrack-like thing, which detectors are being hit, or how many times the detectors are being hit. And could you play this video here? Let's animate it. This is a 2-dimensional array of neutral atoms if it works. If it doesn't work, not a big deal. So 2-dimensional array of neutral atoms. The red is highlighting where quantum entanglement is taking place. And if this worked, it would show qubit shuttling, which is moving the atoms around to show how all of the atoms can be connected with every other atom. You can move atoms aside as a kind of memory. You can move them aside so you can measure certain qubits without disturbing other qubits. So that's a real demonstration that took place recently. Next slide, please. So the state of hardware, IBM, well, Atom Computing announced a computer with 1,000 qubits, but it's not actually available yet, so I'm not counting it. Then IBM announced a quantum computer with 433 qubits, but 433 never worked. It briefly worked with 414, but that's now offline. So the largest quantum computer publicly available that you can play with today is the one on the right, Quera's Aquila, with 256 neutral atoms. The next largest after that is IBM's at 127. They have a few of those. And then the numbers drop quickly because these things are really hard to build and they're really expensive. So the first goal was to build universal quantum computers that can do all kinds of computation. And it's very hard, so one of the trends is building special quantum computers that maybe do one thing or a few things really well. So in the case of neutral atoms, they are a natural fit for solving certain combinatorial optimization problems. So even if it doesn't solve everything easily, if you take problems that we can't solve that are important, and now we can solve them, that's still a big deal. Then new types of quantum computers that are being researched, the electron trap. So you have an atom and you pluck off the electron, which has a negative charge, and that leaves a positively charged ion. And you trap that in a vacuum tube and you control it with lasers. But now imagine you pluck off the electron and you throw away the atom and you keep the electron in the trap, and then you combine superconducting technology, refrigeration, and microwaves, and the electrons become the qubits instead of the ions. Cat qubits are a type of superconducting qubit, except that they are resilient to bit flip errors. There's 2 classes of errors, bit flips and phase flips, and error correction has to address both. So if we can develop a type of qubit that eliminates one whole type of error, we only have to worry about one, and that might make useful quantum computers available sooner. Then topological qubits are theoretical, and there's a dimension of time in here that it's a two-dimensional array of qubits, but a third dimension you can visualize as time, and the information is encoded in the movement of the qubits. The qubits are physically moved around, and that movement is where the information is, but still theoretical. But the advantage to that is they're supposedly very, very resilient to errors, that we might be able to use one topological qubit instead of maybe 1,000 superconducting qubits to achieve the same thing. Then work's being done for native gates. So IBM, for example, has only 5 operations that a quantum computer does. Everything you do gets broken down into those 5. So if we could add more, so that the Toffoli gate, which has been in the lectures, is decomposed into quite a few operations. And so that takes time, and each operation can produce an error. So we can shorten the amount of time it takes and reduce the amount of errors by creating more native gates. So the University of Berkeley has created that one. Next slide, please. Then this has nothing to do with quantum computing, but it shows how the technology overlaps. So neutral atoms, for example, they can be used in quantum computing, they can be used in clocks and sensors. A Bose-Einstein condensate is the 5th state of matter. So you have solid, liquid, gas, plasma. Then Bose-Einstein condensate is really interesting, and it's the same general technology as a neutral atom quantum computer, but when you entangle qubits, the state space grows exponentially. So we entangle 2, we grow the state space. We entangle another qubit, it grows exponentially. We entangle another qubit, it grows exponentially. This works differently. You cool the atoms down to nanokelvin, so billionths of a degree above absolute zero. And then you have a group of atoms, maybe thousands of atoms or more, that all behave as one atom. They kind of like lose their identity, and they're just this clump of one atom, even though it's physically thousands or more actual atoms. Next slide, please. Then a quick joke, 2 atoms, one atom says, I lost an electron. The other one says, are you sure? And the other one says, yes, I'm positive, because an electron has a negative charge. These are atoms commonly used in ion traps, and they are typically positively charged. Doesn't mean they have to be, but normally are. And then this is an image of an ion trap here. Although it's important to remember, you can't actually see atoms. They're empty space, but we can illuminate them with lasers, and we can see the photons, or we can use them to cast shadows. You illuminate detectors on the back, the atoms are absorbing or reflecting photons, and the atoms actually cast tiny shadows. Next slide, please. Other trends, we're moving classical logic to the quantum processor. So what you'll typically do today, you've got code on your laptop, you run a quantum circuit, it comes back, you do some processing, you send it to the quantum computer, it comes back. It's very, very slow. So the idea is you take all of your algorithm, whatever it is, you send it all to the quantum computer, it does the quantum stuff, it does the classical stuff, you get it back one time, you do your post-processing, and you're done. Also, more emphasis on analog. What we've been doing, or what we've been talking about, is digital quantum circuits and quantum gates. But quantum systems don't behave that way. They're continuous. They don't act in these little pulses. So analog versions have less errors because they operate the way quantum systems do naturally. But then you have a hybrid, a software called SuperStack, which allows you to take the knowledge you're learning, quantum circuits and quantum gates, but then optimizing the pulse schedule to try to be a little bit more like analog, so an easy digital interface and trying to achieve the performance of analog. Then also research into qubits. So qubits are two-level systems, and entanglement grows the space exponentially. But a lot of these qubits, they don't have to be two-level systems. They can be higher systems, and then you can see the space grows much faster, so that if you have a four-level system, it's the equivalent of having twice as many qubits. So 5 qubits is the same state space as 10 qubits. 10 qubits is the same as 20 qubits. 20 qubits is the same as 40 qubits. But it's not a small difference like it sounds. So if you have 20 qubits, the space is 2 to the 20th. So that's a million amplitudes that we're talking about. And the difference between 20 and 40 is the difference between a million and a trillion. So the question is, which is harder? Is it harder to build a quantum computer with lots and lots of qubits, or is it harder to build a quantum computer with more energy levels? And I'm not an engineer, I don't have an answer for that, but there is research into this as well. Next slide, please. Then also error mitigation. You're more likely to hear about error correction, which takes place on the hardware. If anyone's a fan of machine learning, you take a quantum circuit that you know what it does, and you send it to the quantum computer, and the results come back. They're noisy, they've got errors, and we create a noise model. Then we take a problem we don't know the answer to, we send that to the quantum computer, it comes back noisy, we apply the noise model in reverse, and that allows us to see what the results should be by using classical machine learning, analyzing the error rates of the quantum computer and applying them in reverse. So you have tools like M3 and Kermit, and that's all that they do. Or you have other software like FireOval, SuperStack, and the Sampler, which perform measurement error mitigation as part of other things that they do. Then you may wonder, as you're playing with the Qiskit blocks and building circuits with 1 qubit, 2 qubits, 3 qubits, it starts getting kind of hard already at 3, and much more so 4, 5. So you wonder, how will I build a circuit with 100 qubits, 1,000 qubits? And we had a webinar recently with the Classic platform, and it's software that's designed to build these large quantum circuits because it'll be really hard to do it manually. Then there are companies like Intel and Microsoft looking forward to the future. We are not going to run business software in Jupyter notebooks and Python. We're going to be using C++ in this case, or Microsoft Visual Studio. We have enterprise applications that are going to do something, and we're going to use these to add quantum computation to it, kind of like using a GPU. But instead of a GPU, you're using a QPU. So there are tools looking in advance to that. Next slide, please. Then on the algorithm standpoint, the algorithms that we want to run, we can't run because the hardware is not good enough yet. So there is this trend towards hybrid classical quantum algorithms, but I'm going to say a few times that there's no advantage to using them, there's no advantage to using them, and there's no advantage to using them, but they're really popular and they won't go away. But we really want to focus on the algorithms we can't run because those are the ones that will do interesting things. There's also a lot of quantum-inspired algorithms which suffer from having quantum in their name. So we're learning from quantum algorithms how to make better classical algorithms, but the important thing to remember is they're still classical. So they're better classical algorithms, they're still not as good as quantum algorithms yet. Then qubits are very sensitive. We lose the information very easily, but we use this sensitivity for things like sensing and metrology. We can measure things with incredible precision. So for example, one atomic clock ticks 485 trillion times per second. And that's what makes the clock so precise. So one thing being looked at is, instead of fighting the noise of a quantum computer, is there some way we can use it? Can we do quantum computation without error correction, without error mitigation? Is there some other way to use these things as they are in their natural state? And next slide, please. And I'm done. Any questions? Oh, I forgot to do my demo. Hold on. You're not going to be able to see this, but I'll show it anyway. So this is a quantum computer that rarely gets used. It's a website called Quantum Inspire. The company is called QTech. And this is already pre-made because I'm one-handed, but there's a Hadamard gate that creates a superposition. There's a CNOT gate that creates quantum entanglement, and then there's a measurement, and there's the topology of the device and a bunch of other information. And I can't do this one-handed. Run button, and I'll just use the default stuff. Return to editor. Come on. And go to the results page. And this is a real superconducting 5-qubit quantum computer in the Netherlands, where everybody's asleep right now, so nobody's using it. And nobody really ever uses it because IBM is so popular. But because IBM is popular, and this will never complete while I'm talking, it's running right now on a real quantum computer, and it should be done any second now. And there it goes. So even though this is an IBM hackathon, there are other quantum computers out there with varying degrees of popularity. And there is the results. So if we had an IBM example, we can see that this device is noisier than IBM. So that's another reason why IBM is popular. But for purposes of a demonstration, nobody uses this quantum computer. So it's my personal, not really, but I use it for demonstrations because nobody ever uses the thing. But we just used, or you just witnessed, the use of a 5-qubit superconducting quantum computer in the Netherlands. So any questions? Is anybody still awake? No? Everybody just wants to do the hackathon? Well, if anybody has any questions later, I'll be here all day.
All right, thank you so much, Sir Malik, for the discussion. All right. So at this point, once your institution is called, please stand up for everyone to get to know the schools that are competing this hackathon. So first up, ladies and gentlemen, let us all welcome CITU Computer Science Program. Please sit down. Next is we have CITU Computer Engineering Program. Thank you so much. Next up, we have University of San Carlos. We have the last three. I'm sorry. Next up, we have University of the Philippines, Cebu. Next is we have USJR Computer Science. Thank you. And lastly, we have USJR Computer Engineering. Thank you so much. So you already know who the what institutions are competing for this hackathon. At this point, for the mechanics of this hackathon, may I call on Javis Aison to discuss the mechanics for the competition proper.
Okay, hello. Hello, everyone. So yeah, we're a few moments away from the hackathon proper. Okay, so for the mechanics, the challenge will last for 2 hours from 2 to 4 p.m. And the students, you will solve, students with coaches, sorry, will solve as much problems as you can. The total time will also be recorded. The items will be scored differently depending on its difficulty. You can skip around if na-stuck kayo to solve whichever problem you like. So the first part of the challenge has 14 items and the second part has 15 items. You would have proctors that will be assigned to you. They would watch you and confirm as you progress through the questions. Now, so as you solve it, sabi nyo, ay, sir, this is our solution, and then try it, and then makikita nyo if masolve it. And then they will check. We have a score sheet for that. And then participants and coaches are not allowed to use the internet. No, wala mo ng GPT. And written notes are okay to use if you have some written notes. The app that we'll be using also has its own information built in, so you can read on that. Also, scratch papers will be provided for written solutions. And lastly, participants will only use the provided laptop for easier tracking. We're very sorry, we announced that you need to bring. But yeah, just for easier tracking, no, we will just use one laptop per team. We will provide those laptops for you. So for the moment, yeah, we will give you 5 minutes to please clean up everything. No, we will check it so that no unnecessary. And then after that, we will have a demo read. Okay, so 5 minutes. Just a moment, guys. Just a moment. And then next.
Hello. So yung coaches can stay at the back na lang. The students will compete. So yung dito sa team dito, dapat yata kasi USGR din yung team yun. In-arrange kasi natin USGR din sa do we have to separate them? Can yung UP, can we exchange the UP with the USGR team para hindi back-to-back yung USGR team? Where's the UP team? Exchange places lang siguro. Kasi may strategic positioning. So yung sa USJR na computer engineering, 3 lang po, and then the coaches will stay at the back.
Alam mo nila yung math na yan. Sagot nila sa kanila.
Tapos, oh, demo mo lang.
Paano ma-qualify yung sagot?
Oo. Ito yung fly mode.
Pati yung fly. Para ma-recuperate lang sa political.
Wala daw ba extra t-shirts for them?
Ubus na tayo. Pero pwede natin padala lang.
Papadala na lang.
Oo, kunin ko lang yung size.
Yung isang may extra shirt kasi hindi pwede bang ibigay na lang natin sa isang tao?
Yes, ma'am.
Oo, sige sir.
Oh, sorry. Ano gagawin lang? Share lang.
Are they allowed to go to the bathroom every once in a while? Or we can announce it today right now. We can go to the bathroom now. Kasi later na.
Ah, sige. Ano ba lang? Ayan, mas mahal.
Just for the information of everyone, you still have time to go to the bathroom. Okay, if the competition is about to start, you're not allowed to go out already anymore. Okay, so you can go to the bathroom, do whatever you want. Thank you.
Power nap.
Yung kapatid ko na lang. Del. Oh, right. Ah, so, kompleto na. 6.
I don't know. May available pa pang
Si, yung kapatid ko will be available.
Sir Elmer, Sir
You can do the double checking. So they can answer questions. Oh yeah. Yeah. You can do that. It's a puzzle I can't solve. Bigyan mo na lang sila ng ano yung role niya. Ikot-ikot na siya for their questions.
Oo.
They can answer.
Magpa-proctor ka, Ed, no? So, ilan na? 1, 2, 3, 4. Kompleto ba 6? Kompleto ng 6. 6 proctors, kompleto na. Ah,
Depende lang. Oh,
Um, final check now, surroundings and demo, and then time to start. Then,
Jabez, alam na nila yung mga hindi sagutan?
Okay. Yung naka-shaded. Will I need to ask them kung tapos na sila kung pwede na presentation, for example, kahit hindi na nasagutan. Pero kung surrender na sila, they just inform me na tap ko na lang.
Actually, the software is designed to teach quantum computing, so all the like helps in the game are meant to. We should be cool.
Kuya, picturean ko kayong tatlo. One more.
Kasi yung ito PSCS na si IPU, may hagkama si PE, pero dalawa yung SGR. So how do we distinguish them? CS tapos yung isa.
okay, mag-clear mo muna tayo ng software nila. And then they'll have the demo. And then start na tayo. Okay. Alright. So, before starting, okay, so we will be checking your cables. So, pakita ko na po yung mga phones, no? Yeah. Or much better if written notes is okay. Yeah, pero yeah, you can search the internet.
Lagay na lang po sa floor. Yeah, your proctors would be... Sige. Alam mo ano yan, lastly, okay. Alright, sige. So we will have a demo, a short demo for this. The app is Mind Test, and then within that, para may mod siya, Biscuit Blocks. Okay, so basically, para Minecraft, pero it's quantum. So, yeah. Okay.
Okay, so guys, okay, so we will be playing a game now. Okay, yeah, so I have to install it first, but you don't need to do this.
Okay, so yeah, you search like the mod, Kiskit Blocks yung pangalan. Okay, then you install it. And search lang, then install. Naka-install na sila, so you won't have to worry about this.
Just wait.
Okay, so originally mind test yung nakalagay dito. But when you select this, mag-iba siya into Biscuit Blocks. So make sure lang to do that. And then create a new world. You can name it whatever you like. Yan. And then see this zero flat terrain. And then select yung Biscuit Blocks here. Yan. Kayo yung mag-create ng sarili ng world. And then na-create na siya, play the game. Yeah. Minecraft talaga. Okay, so we have this.
Okay, so okay. Are you familiar with Minecraft? Okay, that's good. So use letter W and go to the. So you will be doing 1 and 2. Go to 1 first. Okay, that's the portal. And then here you can see that there's the on the board on the wall. There's item number 1 over 16, and this is your puzzle. Okay, so for example, this one here, convert 0 to 1. Okay, how would you do that now? So you go into your chest, and then you right click, get this, and put this into your inventory, and you do a right click here. Okay. And then if it turns gold, which means that you've answered it correctly. Okay?
Yeah. So as you can see, the water indicates the level of probability. In this case, from 0, ito naman siya into fully 1, di ba? So as you can see, ito yung mga states na possible. Dito walang probability na 0, and then 1 siya lahat. Okay? So kapag nakita nyo nag-gold ito, you got the correct answer, or na-satisfy yun. At that point, pa-check na kayo sa proctor nyo. Okay? Pakita nyo na we were able to solve this problem. And then they will loud kung ano your time.
And also the arrow, okay? Arrow going that way is positive. Going the other way is negative, no? And it can also go upwards.
Okay.
Okay, I think that's it, no? Oh,
Okay,
okay.
fly mode. Okay, so originally, no, you have to go through each sequentially, like tapos mo muna lahat. Pero we will allow you to skip around, no? So we will enable fly mode.
So, to enable fly mode, you click letter T, and then just say grant me no clip. Okay? And then enter.
Sulat niyo yung mods.
And then H for no clip enabled, and then K for fly mode enabled. So this will allow you to go through walls. Okay. So if you cannot answer, if you think that you're spending too much time on a problem, you can go to another problem and go back to the other one.
Okay, so again, ano yung answer?
Yes.
/ grant me space no clip.
Yeah. So grant me no clip.
No clip. Ayan, okay.
Yan. Enter.
Enter nyo lang. Okay. And then ano yung mga answer? H and then K.
H means
Okay.
enable, no? So it's a toggle, no? So if it's disabled, then you enable it, and then K, fly mode, no? If it's
Fly mode
disabled,
sa same lang pa sa Minecraft. I-double tap nyo lang yung space. P. Yung chat.
letter T.
Parang chat siya. Letter T. Okay? Any questions before sa fly mode, H pati K. So, experiment na lang kayo on what works.
Tsaka ano din pala, no? There is an instruction, no? If you click on the question mark, it will give an instruction, and sometimes it will mention the special key, no? Special key. It's the letter E. Just click on the letter E. So instruction. Okay, so for example, this one here, no?
Yeah, you can read.
Yeah. Read the instructions if you want, or if it's already obvious, you don't need to read instructions. If it's not obvious, read instructions.
Okay. So, yeah, the proctors would be hands off except kapag mag-score na sila. And if they do see some inconsistencies or fraudulent activities, yeah, they would also notify us. Okay? So, yeah, you won't get any answers from them. Yeah, you can use your mouse. Okay. Anong block po? Yung ano. Kapag na-misplace ko yung block.
Pag na-misplace mo yung block, yeah, you can destroy it again. So you can just, for example, so to place a block, you right-click. To remove it, left-click.
Parang sirain na lang sa Minecraft. Punch nyo lang siya.
So for example, this one is if I click using left, it will destroy it. Yeah.
And
Tapos,
balik yung ano.
pag gusto mo ibalik, right lang ulit. Sorry, I have to get this first. Yeah.
Hindi na lang ulit sa chest.
Yeah, and then right.
Okay. Alisin lang natin itong sa kanang sa. Okay, sige. Any more questions before we start?
They will be the one who will inform the proctor na okay na yung
Yeah. And then the proctor will check if satisfied. If nag-call din. Yeah. And kung
kailangan i-validate ng proctor.
i-validate po ng proctor. Okay, it's 2:13. Ayan, sige. Do your final, we'll start at 2:50. Okay. So do your final preparations. 2:14 na. Yeah, last 1 minute. Wait, wag po muna. And Yung mouse. Sige, go ahead.
Pinalik ko lang sir.
Okay. 5, 6. Okay. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, go. Go. Sige. Dahan-dahan lang sa ano. Yan. Share natin.
Dahil ilahan ni buhat sa circuit. Walang ipakita ka. Naran pa ko.
Ay, balik ilang iipon. Ang
1 hour left. So far, technical issue.
Silang ko. Extension sa lang sa akin. Gagamitin natin.
Side issue?
Doon nag-start na. Hinintay na lang natin. Pero dito po speaker namin Ilan yun? Taiwan? Wow. Ano ba yung university? Nag-speak mo siya sa UCR?
Hindi, sa organization namin.
Okay. Ano ba? World Activity? Okay. Hindi lang yun.
Isa ka. Speaker namin siya regarding sa computing.
Ito pala si Bobby.
Yes.
Coach ka ng SDR. So yung team mo? Ito? Di ba dalawa ka?
Ito is sa website.
Isa sila?
Sa amin naging naging question sa pagano niya pagkatao niya. Practical design namin.
May picture ko. Adoption siya. One story. Tapos, there was the topic. He was and then, lumipat siya. And then, during that time, sabi niya, we're actually tomorrow. Yun, nag-rally ako. Tapos naman sa every day, meron project, smaller class. And I thought, humingi ng tulong. And then, nagsabi ako sa isang mga member ng team. We actually have and then may nakita ko ako there's a writer Sir Brian Buti na lang transfer ko. Hindi naman sa buti na lang. Buti na lang nagkataon. Buti na lang nagkataon. At least bukas na. Ay, may phone ko man.
Remaining time is 13 minutes left.
Okay na. Charging. Saan ka na naman sir? Lobat na naman. Kalati. Lobat. Kalati. Hindi mo. 3 minutes lang siya na. Pero okay na. Okay na. Sana kay dashboard or leaderboard sa akin. Yung plano, hindi ko alam tapos day na ng jacket. Hindi refresh. Kaya lang ako ako. Babalik naman kayo dito. Intense dito. Sino kayo Babasa lang. Ito? Kilala mo si ano yan eh? Oh, Astig. Jet. Lagi kami nag-uusap.
Minutes left.
Wala, basta mawala na siya. Dili mo rin ang Moro man yung gikuan, kaso na So, okay, ito yun. Tuloy siya. Iba na lang natin. Yung server. Over 16 ang question. Ah, na. 11 over 16.